As we were just saying, last day on proofs, our last new lesson, everything else is review after this. Today, what we are going to be talking about will be things with rectangles. And we did some stuff with all those different shapes and properties of rectangles and parallelograms and rhombuses and all of that, but you haven't looked at it in a while and you're probably a little bit rusty on it. So we're kind of reviewing some of that. Now, ever since, I don't know, preschool-ish, you've known that that if you have a shape like that, you call it a rectangle, and you kind of knew, oh, you may not have known the word right angles or 90-degree angles or perpendicular, but you knew the corners did that. They came together in that kind of a shape, even if you didn't know the name of that sort of an intersection. And you kind of got the feeling that, okay, these opposite sides are parallel. You didn't know those terms, but you looked at it and you knew that was a rectangle. And so we're going to mark on it that these opposite sides are parallel. Now the top is not parallel to those two sides, so I can't use the same mark on it, but I can also mark with a double parallel arrow to say the top and the bottom are parallel to each other, just not to the left and the right. So basically our definition of a rectangle is a parallelogram with 4 right angles. Because it's a parallelogram, remember we did talk about a lot of other properties of parallelograms. One of them was that opposite angles are congruent. Well, if they're 90 degrees, of course they're congruent to each other. So that one doesn't really give us something new. Opposite sides are congruent. We can mark that on here. That's a property of a rectangle. The left and the right have to be congruent. The top and the bottom are a different measure, so we'll use a different congruency symbol there. We also have adjacent angles are supplementary, so if we add those two, we get 180. Well, we already know they're both 90, so of course we add them and get 180. That was just reminding us of the parallelogram property that those two angles would have added to 180. One that we haven't gotten up here that may help us on some proofs where we're given, this is a rectangle, what else can you say about it? It may help us to be able to say that the diagonals bisect each other. That means if I draw this diagonal in and this diagonal in, each diagonal is now cut into 2 equal pieces. I'll clean up my marks here in a minute, but for right now, it's saying those 2 pieces are congruent. And it says the other 2 pieces are congruent to each other. But there's one more property since this is a rectangle, and that is that the diagonals are congruent. So if those total diagonals are congruent to each other, the half diagonals are congruent to each other, which really means these are 4 congruent pieces here. So I'm going to mark them so they all match. I'm going to use 3 tick marks now since I really had already used 1 tick mark on the left and the right and 2 on the top and the bottom. I really ought to have something different. So does that make sense? As I was saying in a proof, then, if you are given that it's a rectangle, now you can say any of these things about it because of definition of a rectangle or property of a rectangle or something along those lines. So let's do an actual proof where we are given that it's a rectangle. This is the last one on the front of this problem set that I am giving you now. So as you get your paper, go down to the bottom one on the front where it says page 508, number 5, copy your picture and draw your T-table so that you can fill in the proof. All right, so you've got your picture, you've got your T-table, and who can tell me what I do for my first line? Kaylee? Reason? You're getting good at this so far, you guys. What about my second line? What am I going to do for my second line, Melissa? And that was also given. Okay, I have not yet said side congruent to side or angle congruent to angle, so I'm not yet ready to mark anything else on my proof. We're going to have to figure out ways to get there. And so let's see, what could we say since E is the midpoint of AD? I'm going to start with that one just because we just get that whole long list of things for rectangles. So there may be a bunch of things that we're going to have to pick and choose from on the rectangles. I think it might be a little bit easier. What can we say because of number 2? If E is the midpoint of AD, what are we going to be able to mark on the picture and then write down in our proof, Riley? Excellent. I love the way that you switch the order around. So AE is congruent to DE, and that was definition of midpoint. And I'll talk about why that's the correct order in just a moment. I want you not to write anything else down for a minute. I'm going to make some other marks on the picture as we talk about and try to figure out our strategy here. And then I will erase them so we really mark them as they're actually in our proof. So you guys wait to do it. We want to show that, let's see, BE and CE are congruent. We want to get there. And when we've been trying to prove two sides are congruent, what if we had to use at the end of the proofs to say that when the final thing has been this side's congruent to that side? What have we had to say there, Mateo? CPCTC. If we want to use CPCTC, what do we have to show first? Congruent triangles. So I'm guessing to do that, we're probably going to need to get some congruent triangles in there. And I see 3 triangles up there. I see a top left, a top right, and then I see one down at the bottom. Which 2 of those 3 do you think will be our congruent triangles? Just as you're looking at the picture. Grazie, which ones are you pointing to? Top left and top right. So far, all I have is 1 congruent sets of sides there. I'm wondering, and we haven't used any of the properties of a rectangle yet. That's the only other thing that's given that we haven't used yet. I'm wondering, are there any of those properties of a rectangle that might let us mark enough things on there to say congruent triangles? Daniel, what's something else we might be able to mark? And do you remember why on that? Well, it was one of the properties of a rectangle. The opposite sides are congruent. So we're going to be able, don't mark this yet because it's not written in our proof yet. We're going to be able to say those opposite sides are congruent because that's a property of a rectangle. Kaylee? Is that really going to help me to say supplementary, or is there something else I can say about angles in a rectangle that's more helpful? So we can say that these are right angles, and then are right angles always congruent? So if we have those sides, those congruent angles, those sides, will we have enough for congruent triangles? Everybody shout out what would be the reason. SAS, so we have our strategy in mind, right? So let me erase what we've marked so that we only put them in there when we have actually put a reason in the proof. I'll leave those highlighted that we're trying to find that. I'll also go ahead and say, since we think it's the top left and top right triangles that are congruent, when we wrote AE, that started at the right angle and then went away from it. So this one, if I did ED, would not be starting at the right angle in the second triangle. So that's why we needed to flip it to DE. So one of the things that you guys said was that side AB is congruent to side DC. And I think I'm doing that correctly again for the same reason. Start at the right angle and go away from it. Start at the right angle and go away from it. And that was property of rectangle. So you see why we wanted to review those. You guys also said angle A, angle D are right angles, and that was a property of a rectangle also. I can't mark it on the picture yet, because on the picture I want to be marking congruent angles if I'm going to be using SAS. So if they are 90 degrees, does that mean they have to be congruent? So we are going to then say, and then we'll mark it on our picture, angle A is congruent to angle D, and our reason is all right angles are congruent, and so we'll mark that on our picture. Do we have enough marked on there now? And what's our reason again? SAS. So now we add to our proof. SAS, that our triangles are congruent. So be sure we put triangle symbol, not angle, on this line. And the first one I can name any way I want, so I'm going to say ABE. Is congruent to triangle. All right, A in the left triangle corresponds to and has the same measure as which angle on the right? D. So D has to start that one. A and D are corresponding angles. Side AB, so my first two letters, was marked with 2 tick marks. So I need the side that starts at D and has 2 tick marks. So D to C, so C has to go next. And then back up to E. So everybody feel okay about that? Then what's our final reason going to be again? CPCTC. Did we show congruent triangles first? We always have to have that before we can use CPCTC. And let's look back at our statement of what we were trying to show. BE, CE in that order. B, CE. And does that match? We wrote BE as the second and third letter, and CE as the second and third letter. Anybody with questions on that proof? Okay, I want to talk about one other thing in conclusion here. It just kind of summarizes something that we just did. If you have a given that you have perpendicular lines, you can say you have right angles. If you have a given that you have a rectangle, you can say that you have right angles. Now, you may want to say you have right triangles if you're wanting to end up using HL, because then your proof has to say right triangles, congruent legs, congruent hypotenuses. But if you want to use SAS like we just did in this proof, you don't care that they're right triangles even though they are. What you need is congruent angles. So you need to say that all right angles are congruent to be able to use SAS. Any questions on anything? Then it is time for you to work on that homework set.